Welcome to the Exploit Development Workshop. My name's Tanner Scott, and I've been with Opta for about 3 years. I have my OSCP cert as well as my EMAP cert. We're going to script in Python and chain vulnerabilities together to get remote code execution. Let me go ahead and share my screen. So I have everything up here on GitHub. Go ahead and navigate to this site here, https://github.com/dreamcast65/juggle and we'll go ahead and get to it. At the top of this GitHub README, I've got some links to some vulnerable applications. You're more than welcome to download if you want to follow along. There's one for VMware Fusion and VMware Workstation. If you're using VirtualBox, you should be able to download the VMware Workstation and use this command here to change it, the VMDK file into a VDI. Otherwise, I am hosting an ngrok location, but it will change how you'll need to write your script. And if you do use that, please come up with a unique name for your shell file that you'll upload. Go ahead and when you have them running, reboot them as well, and that way it will assign a new IP address to your actual home network. Down here we have requirements for Python. We'll be coding in Python. Please use pip install and make sure you have the libraries needed for this exercise. So the vulnerabilities that will be exploited today in this Juggle Me application are an authentication bypass through PHP Type Juggling, and then we're going to have a file upload where we'll bypass a file extension blacklists, and then we'll use local file inclusion to actually execute the PHP code in that file. So PHP type juggling is our first vulnerability. We will be using that for the authentication bypass. The way this works is that PHP will have a loose comparison and a strict comparison. A loose comparison will actually try to convert both variables into a common file type, and then it will compare against each other in that file type. So this means that if we look at this graph here on the PHP documentation page, that true is equal to true, but true is also equal to 1. True is also equal to the string 1, and so on and so forth. So in a strict comparison, true would be equal to true and only true. So it's not equal to an integer of 1 or false. So this is important for this vulnerability because when we compare hashes, we're going to use the loose comparison to compare two hashes that aren't the same, but will say they're the same, which will allow us to bypass the admin's password. So if we see here, we can echo two hashes. We're actually going to be using some hashes that have been found out to have a specific hash that starts with the 0E. When a loose comparison's happening, it will think a 0E is like a float. So it'd be like 0E would be 0 to the exponent of whatever power, and 0 times whatever is always going to be 0. So it's always going to equal 0. So when we're comparing two hashes, we've got some magic hashes up here. These are hashes that have been found to start with 0E. There's a GitHub by Spaz called hashes here. The application we're running here, let's see. the login.php is where you'll find the application. If we look into the source, in the application, there's actually a note saying they're running SHA-256. So we're actually going to go check out the hashes of SHA-256. And if we take one of these strings here and put it in PHP, we'll see that is the hash for that password. We'll take this one as well. And see, we've got two different hashes right there that both start with 0E. So if we do a var dump on this, where this is a loose comparison to this here, we'll see that it does say it's true, but as soon as we try to do a strict comparison, it will say it's false. So when we're comparing these two passwords by hash, it thinks it's actually the right password. So that's how we're going to bypass this first login. So we'll just take any of these here, go to the login page, type in admin, paste. Let's go ahead and throw this through a proxy too. So we've got Burp Suite here, running it. This is going to be the post request. And forward. And now we're to a file upload page. So that's the first vulnerability. Our next one, we have to do a file upload. So we're going to try to do a PHP reverse shell to get remote code execution. So you can find that in user, share, web shells, PHP. Let's do a PHP reverse shell. Let's see, it says, PHP is not allowed. So let's go to intercept that again. Let's do simple backdoor this time. We're going to change this from php.png or a file extension bypass. So that was successful, right? So there's a lot of different file extension bypass techniques. I have some listed here under file upload, and you got a file extension bypass cheat sheet here. If we open that, it's not wanting to load. Okay. So if for some reason PHP doesn't work, you're more than welcome to try all these other extensions that can actually run PHP. Depending on how the web server is configured, one of these may work. I did a php.png file, so it thought I was going to be uploading a file image. So if we try to go navigate to that, you see it doesn't actually render the PHP code. So there's actually another vulnerability in here. If you look at this logout page, it actually redirects to include the page logout. So if we actually redirect to the file we made to be included, you can see it is actually running PHP shell we uploaded, so we can get, commands being ran from there. So that would be the file extension bypass on that we're going to be writing this Python code on. So we're going from the PHP type juggling for the authentication bypass. We're bypassing the extension for the file upload, and then we're using the local file inclusion to actually run the PHP code that was in that PNG file. So the libraries that we're going to be using today are requests, subprocess, time, and argparse. Requests is going to be making all the web requests that we're making to the application. Subprocess is going to be what we're going to use to execute our reverse shell. Time is just going to be to give the request some time to be made. And argparse is actually going to grab all the arguments that we're going to use in our Python script. So one useful extension that I found in Burp is this Portswigger's copy as Python requests. Go ahead and download that. We're going to use that in this workshop. So you should be able to just download the app, and then once it's downloaded, you go come to Extender, the App Store, and then there's a manual install button down here. You'll hit that, select the file, and install it. And once it's installed, you'll find that it's right here in the burp extension. So we're actually going to use this to grab some code for a shell to go in our script. So let's go ahead and grab that right now. We're going to put this PHP reverse shell up here and run it. Oh, I'll turn the proxy on first. All right. So we're running this PHP reverse shell. We're going to submit. And when you have this burp suite extension installed, you can right click and just hit copy as requests. And I'm just going to post it right here. So it actually took the PHP reverse shell as well as everything. See import requests. The part that we're going to want for this right here is going to be where the PHP code starts and ends. Instead of just telling Python to upload a file, we're going to include this in our script. Okay. And so when we're starting to code, this is what we're going to want to start with, is the starting of the code that includes the imported libraries. Go ahead and open up whatever IDE you want to code in. And we're going to start our script. So be sure to import all these libraries here. PyFiglet you don't really need. I just have that to create a banner for Source ZeroCon. So if you want to make your own banner, that's fine. Proxies, if you want to troubleshoot your script at all, and you can actually proxy your information with requests into like a burp suite if you want, and actually see the requests that are being made. That could be useful if maybe your script's not working as intended. The loaded file is going to be the file we're going to upload. This next part, files, is actually going to be the contents of that file being uploaded. So here we have just the simple shell. What we're going to do instead of that is we're going to take what we copied earlier from burp, and we're going to put that instead. So instead of creating a web shell, we're just going to have the reverse shell TCP connection being sent. We're also going to have to go in here and find where it says change this, the IP and the port. So we're going to actually change this to, say, localhost. So that's going to include whatever localhost information we put in our arguments later, and then as well as the port we're going to change. These are going to be variables we're going to assign here in a second. Okay. And then we also want to create a class. So in here, we are going to start declaring our functions. We're going to do an init function. It works as kind of like an instructor or a constructor like C++ and Java. So here we're going to say init, and then we're going to say self, and then we're going to start listing out the different variables we're going to assign and work with. So we've got the target IP, which will be the application we're attacking. The local host and local port is our attacker machine that we're going to send a shell back to. So once we have this written, let's see. We're going to assign each one to the self of itself. will be the end of the init function. And then we're going to have an exploitation function as well. And in here, we're going to assign the URL, the IP, and then we're going to use the requests library here to create a session. So let's go ahead and print something here saying solving URL. And we're going to do request one is going to be to get the URL. We're making our first GET request. We're going to let it sleep for a second. Next is that we're going to log into an application. So for this, we're going to need some login data. If you look at our, let's see. If you look at our login data here, if you want to just grab it from here, you're more than welcome to. You can go ahead and copy requests and paste it again, and you're going to have your data right here. So it's basically just grabbing the user, the password, and then it's saying in the post data to have the login. So just grab this here. And then from there, we should be able to make our second request. And this will be a post request with the URL plus login.php page. And then we're going to have the data equal login data. So if the request status code equals 200, then we're going to say login successful. Let's see. Else we're going to say and then this will quit out. And after that, we will, let's see, we'll make our third request here. And this is going to be the file upload. So that's going to the home page. And the files are going to be files. I did earlier. And give it some time to make the request. So if the request 3 status code is equal to 200, we're going to print upload successful. Else, it's fail. And quit. So there's basically going to be our file upload of what we need. Now after that, we're going to need to make our Netcat Listener. So we're going to set up that next. And this is where we'll be using the subprocess library. To do that, is a variable listener from subprocess .p open. This is going to actually run Netcat for us. So use the local port that we assign. Give it some time. So now that that is running, now we have to make one more request, and that's to execute the PHP file that's going to give us our reverse shell. This has to be a GET request, URL plus home.php, and we're going to use the LFI to call our shell that we're making. We're going to tell our listener to wait. So if R5 status code equal to 200, we're going to print it worked. We're going to tell the listener to wait. Else, we're going to print fail. And tell the listener to terminate. So that's going to be our exploit class that we've created. We do need to define the arguments we're going to use. So we're going to make a function called getArgs. This is using argparse. So we're going to name a variable called parser and argparse argument parser description equals juggle me the 0.1.0 RCE. we're going to take that and we're going to add arguments to it. The first one we're going to have -t target. Destination is going to be URL. Action required equals true. Action, restore it. Help equals might be parser. So we need target IP, target port, listening IP, password, and login are going to be the arguments we're going to be adding. So we're just going to add each one here. Okay. IP. Let's see here. Gotta get the listening port as well. And then password and login. So After that's all done there, we'll say args parser parse args, parse the arguments, and then we're going to return the arguments. So we're going to jump out of that function, and at the bottom of our script, we're going to put args and run the function get args. I'll get all of our arguments. We're going to assign target IP from args URL, target port equals args dot target port, localhost equals args dot localhost, local port equals args dot local port, login equals args dot login, password equals args dot password. Then we're going to run our exploit class, create an exploit class out of exploit target IP, target port, localhost, local port, login, password. So we're putting all of our variables in there. And that exploitation is going to run the exploitation function that we have in our class exploit. And that should be it. So if we go Python new exploit, invalid syntax. Okay, give me 1 second here. I think we're missing a, yeah. For my typos. Well, instead of going through all these typos, I do have a working exploit that's pretty much the same thing on here instead of just dealing with syntax errors. So I'll go ahead and show you guys that. So it's the same thing we were writing here with the same shell. Let's see, so it's going to say the usage down here is going to be P for URL, P for target port, L for localhost, P for local port, password, and login. I do have that all up here already typed out here. So you see it's running the shell or the Python script with the target, the port. So that's the website, local ports, attacking machine. This is the password we're going to use, and then we're going to log in with admin. And if you look here, we're on the Juggle Me machine, and we're in www data. And so, yeah, it's basically scripting out all of your steps so you get remote code execution with one click. That way you can create exploits for exploit DB if you wanted to, some findings that maybe you've researched. So anyway, that's the end of the workshop. Does anyone have any questions? They can reach out to me. My name is Dream on the Discord, DR34M. And yeah, I'm able to answer any questions, and that should conclude the rest of the workshop. Thank you for your time.